Hi, everybody. Welcome back to Dave's Math channel. This is my next video and my feature on the Math Lovers book, and I'm up to section 2.7 of the first volume. That's on chapter 2, which is on real numbers. And today I'm going to talk about scientific notation. This is lesson 2 of section 2.7, which is on really large numbers. So, anyway, let's begin. And this slide might be a little hard for you guys to read, but here's where I define and describe scientific notation. You guys might have already learned this. I think most high school students learn scientific notation. It's just a compact notation for representing either really, huge, really large numbers or really small numbers. And it's very convenient because you express things in terms of powers of 10, basically. So instead of writing a million, we would write 10 to the sixth. Instead of writing, a trillion, you write 10 to the 12th, and you can even go bigger or smaller. I mean, like I think I mentioned in my last video that the observable universe has about 10 to the 80th elementary particles of matter. You could also represent that as a number, but it would be very cumbersome. There are names for numbers that big, but I don't even want to try to use the name for whatever that number is. It's just more convenient to work with scientific notation, but you just have to kind of get a feeling for how really huge or how really tiny these numbers are. So I think I'll just start with a few examples here. I give an example on this slide and the following one. I think the example I show on the bottom here is a very small number. Say we wanted to represent 3.8% is in scientific notation. Well, percent just means over 100. So that would be 0.038 if you wrote it as decimal. But the way you convert that to scientific notation is for numbers that are smaller than 1, you count the number of zeros before the leading digit, which in this case is 2. Remember, the convention for writing numbers that are less than 1 is you put a 0 before them. So 0.0, that's 2 zeros, so that means your exponent is minus 2. It's negative because it's less than 0 if the number is less than 1. So you know that your power of 2 is 10 to the minus 2. And then the thing that's left over is called the mantissa. So the mantissa in this case is 3.8. It's always between 1 and 10. It's always at least 1 and less than 10, strictly less than 10. So the scientific notation for 0.038 would be 3.8 times 10 to the minus 2. And that's approximately the salinity of salt water, I believe. I'm not sure if that's why I picked that number. But here's another example. Suppose we want to represent, this was when I wrote this book in 2022. This was the population of the Earth in I think it was 2022. Can't remember what year, but at the time I wrote this, the population of the world population was, I think, 7.684 billion. How would we represent that in scientific notation? Well, billion is 10 to the ninth. So we just write 7.684 times 10 to the ninth. And you can do even bigger and smaller things. I mean, I might as well give you a few other examples. You want to see a really big number. You know how many possible chess games there are? Turns out this has been estimated. There's approximately 10 to the 120 possible games of chess. That's even more than the number of elementary particles in the observable universe. Number of possible games of Go is even bigger than that. It's about 10 to the 193. Yeah, and I've seen big numbers in physics and small numbers. So if I can think of some examples of some really small numbers, I know the Bohr radius of the atom is about, what is it, 5.29. It's about 0.529 angstroms. An angstrom is a 10 to the minus 10 meters. So it's about 5.29 10 to the minus 11 meters. And that's not even really that small when you deal with scientific notation. You can get a lot smaller than that if you want. I don't know. Can't think of any good examples right now of something that's really small. Probability of getting a royal flush is, I think it's 1 on 649,740. That's just in the first draw if you're playing draw poker. And that's, what is that, about 1.6 times 10 to the minus 6. So That's not even probably that small. But I think you get the idea. So that's scientific notation, very powerful notation. And that concludes my video for today. So thank you for watching. Long live math, and I'll see you guys next time. Bye.